A city's metropolitan transport system operates 6 bus routes A, B, C, D, E, and F, and 128 buses. The number of buses apportioned to each route is based on the number of passengers riding that route. The table below shows the daily average ridership in thousands on each route. Find the apportionment of the buses under Jefferson's method. And then we're given this particular table. Now, the thing that you want to do in order to get these done easily using Jefferson's method is to use the Java applet that is included in MyMathLab. Left click the multimedia library, and that will bring up this window, and you want to left click the radio or the checkbox for Java applets and left click Find Now. It may take a moment, but once you do that, scroll down and left click Apportionment Methods, and this table will, or I should say window, will pop up. This is a Java enabled window. My recommendation is use Firefox since Chrome is no longer supported for MyMathLab and Chrome no longer supports Java natively. So once you have this pulled up, you want to create a table. You'll left click Create Table. You'll notice that you have state A, B. Well, you need a total of 6 because in this problem there is A, B, C, D, E, and F. So down here, let me just make this a little wider. On the left or on the lower right hand side, you can increase the number of states. Now this doesn't, when they say states, we're just talking about the number of particular items that we're looking at. We also need to increase the number of seats. In this case, we're looking at 128 buses, so type in 128. Now we have the 6 bus routes listed, and now we need to include the populations. You cannot use decimals here, it must be whole numbers. So type 4180 for the first one since that corresponds to the decimal that we have. Do the same thing in the second one. We'll type 3045, and you do need to double click in this field to get it to be where it is fillable. Type in 2052, then we'll type in 1409, then the next one will be 1026, and finally we will type in 888. And you need to click somewhere else so that the field fills and you have this compute button available. Left click compute and it will give you your standard quotas. Now notice that this does add up to 128, but we are concerned with Jefferson's method, so left click Jefferson's method. You will then have a column for state, a column for population, a column for standard quota, modified quota, and modified lower quota. You will note that the value in this total row for the modified lower quota does not match the value that is in the problem, and you will need to increase or decrease the modified divisor in order to increase the total for the modified lower quota. So I'm going to decrease this and I'm going to show you exactly what happens. Notice that as I decrease the modified divisor in the lower right corner here, the modified lower quota increased from 125 to 126. So I'm going to left click and hold on this down arrow key until the modified divisor changes enough that the modified lower quota will increase to the value that I'm looking for, or I should say the target value. Notice it's gone to 127. And now it's at 128. You don't have to worry about stopping exactly when it changes because the only thing that will be changing is the modified quota column. But now let's examine the modified lower quota column. Notice that this now has 43, 31, 21, 14, 10, and 9 respectively. Let's go over to the problem and type in the first value of 43. And we hit enter and we get the warm fuzzy good job message. We're going to do that for each one of these. So 31 for the next one, enter, then 21, enter, 14, enter, 10, enter, and then 9, enter. And we have completed the problem without having to go through the massive amounts of pencil and paper calculations for this particular problem.